Oh my God, we're back again.
We're
Brothers,
back.
sisters, tell a friend. In the words of Backstreet Boys, this is Amster in the Brits Code Corner. If you have not joined us before, we cover everything about coding. So welcome to the show, everyone.
That's a very broad statement.
Everything.
We'll try.
We cover it all, every single
Cover it all as best we can. Something for everyone. There you go. There's the phrase. Something for everyone.
Something for everyone. I love it. All right. So, Steve, introduce yourself to the people, please.
Hello, everyone. I'm Steve, the Brit, as you can tell from the accent. So I'm a developer advocate for .NET and PowerShell at AWS and longtime coder.
I'm the other host, the co-host, if you will, AM or the Amster. I don't know how I got that nickname, but it stuck. So I'm the Amster now. But yeah, I'm also a developer advocate for something called AWS Game Day, which is a lot of fun to play and learn and engage with AWS hands-on. We can talk about that later. We also just did a show yesterday. If you caught that, step up your game day. Mm-hmm. But today we're here for Code Corner. Steve, what is Code Corner and what should our audience be expecting?
Well, we just told them something for everyone, right?
Yeah, but we cut it into different segments, don't we?
We do. We're gonna have two segments. So every show. And by the way, I can see pings coming in on the comments. So please ping us. Tell us where you're joining from because we'd love to hear it. You may get a shout out, whoever's furthest away. So we've got two segments. Primarily Beginner's Corner, where we go over, we attempt to demystify coding, yes. Right? We've been out at events recently. We've had people, or I've had people walk up to me and say, hey, I'm part of the catering staff at the event. I really want to get into coding. Where do I go to get started? What does all this mean? Right. Or I've been reading these books. I don't get this bit, right? So trying to demystify some of that, right? Go through some examples in different languages. We used Python. What is this? Yeah, you go. We used Python in episode 1 a few weeks back. We used C# last time. We're using some C# today. We're going to transition into some TypeScript. And then we have Project Corner, where we have a slightly more advanced project setup, which is equally suitable for beginners because we'll have shown you some stuff in the Beginner's Corner that probably relates to what it is we're going to be talking about, i.e. TypeScript. There's your clue today. Where we just take a project and we do something with it in the cloud, right? So we're trying to display cloud development as well. So, as we said, something for everyone.
There you go. And why would, seemingly you're tuning in on an AWS channel, obviously, on LinkedIn, or maybe Twitch, maybe Twitter. Why would it matter if you knew how to code if you were working with AWS, right? Well, oftentimes, you do have to do some coding, right? Mm-hmm. Either you are a full-time software engineer and deploying out your workloads to AWS, for example, or even if you're not, even if you're more in the security roles or an ops role or even like an ML engineer, for example, machine learning engineer, you still have to engage with some coding. It might be scripting, it might with a language like Bash or Python. But we're covering all those things too, all the fundamentals of learning how to code and then taking those and applying them in the larger projects that we do in the second half of the show.
Yep.
Look, we got a shout out for Boto3 already. Boto3. Are you familiar with Boto now, Steve?
I am.
All right.
No, it's one of our AWS SDKs. How could I not be? I used to work on them. So.
That's true. But you are a newcomer to Python.
I am a newcomer to Python, yes. I do know TypeScript, or did. I haven't worked with it for a few years. I suspect everything has changed since the last time I went near it.
Right.
But yeah, I'm slowly learning Python under your influence, which is a good thing or a bad thing. I don't know. We'll see.
With me, it's always both.
I know the first thing you taught me was Dunderscore, which I thought was an insult at first, but it's not.
No, yeah, the Dunder methods. Yeah, double underscore. That's right. Well, the other part about Code Corner also that I love is that we're live with all of you. So we've been, all the episodes we've done so far, opening the floor to you all to questions about programming. What are your fears? What are your anxieties? What's keeping you from getting started? If you're more advanced in your coding journey, what are the things that trip you up? We've been talking all about that stuff around the beginning of the show and all throughout the show as people host their questions. We are monitoring chat, as Steve said. I've got it pulled up all across the different streaming platforms that we're on. So please feel free to drop your questions in. So Steve.
Oh, there's a good one that's just popped up right there from Colin. What is TypeScript used for?
We're going to cover that. You're going to have to watch. You're going to have to watch. We're going to get to that soon for sure. TypeScript, the 10,000 foot view of TypeScript is it's a superset of JavaScript that gives it types, which JavaScript is not a typed language naturally. So
yeah, I think the phrase I've heard said back when we worked with it on one of our extensions was TypeScript is not valid. JavaScript is valid TypeScript. TypeScript is valid Java. I don't see how it can be both ways, but anyway, there was some kind
JavaScript
of
is valid TypeScript.
TypeScript. There we go. Yeah.
Yes, but you cannot execute TypeScript necessarily, depending on what you're using in the TypeScript language.
Mm-hmm.
You can't just automatically execute that in any environment that uses JavaScript, which that's another thing where JavaScript is actually one of my favorite languages, Steve, if you can believe it. So we're going to talk a lot about the...
there we go. Somebody, actually, Nicholas has just nailed it.
Yeah.
Type JavaScript. It's type safe JavaScript.
We're going to go over all the wacky intricacies of JavaScript. And it's got a long history and a very interesting history. And a lot of that's influenced by where JavaScript originated and how it runs. Spoilers, it started in the browser, right? And then moved into server-side language later on in life. So there are some things about JavaScript that it's inherited from its early days. It was also a language, I think it was built in like 10 days by Brendan Eich, I believe is who did it, who famously worked on Mozilla, right? Or no, Netscape. Was it Netscape Navigator?
Netscape. Yeah.
Anyway, we'll get into
time. Wow.
We're going to get into all of that type of stuff to better understand JavaScript and then get into TypeScript and why it matters. But Steve, you've got some stuff to cover today in C#. We didn't get to finish Beginner's Corner last time, did we?
Yep, that's right. So last time out in Beginner's Corner, we were looking at C# classes, right, and how you define class hierarchies. But we didn't talk about how objects, which are instances, right, of classes, get initialized.
Right.
And we also left with some advice around, if you want to learn a typed language like C# and building class hierarchies, one of the things that's really useful to do, that certainly that I found on back when I was learning OO programming in the 90s of all times, was find something in your house, in a room, like some furniture, and go and model it, right? So what I've done is, and one of the things I think I mentioned briefly last time around was when I actually interviewed at Amazon a long time ago now, that I was asked to model the game of Monopoly, right? Which I thought was a curious thing to ask, but it was actually interesting at the time. So I've actually been working on that.
Okay, very
kind of
nice.
show some of these these object initialization mechanisms that we can use. So the game isn't running yet, but I've got enough of a class hierarchy that I'm beginning to work out. So I figured we could go through that code and we can just go through my thought process, because rather than sit down and design on a piece of paper like I would do like in the real world, shall we say, I literally just sat down and started hacking out code.
Yeah.
And then refined it as I went, which is actually another equally valid way of learning something.
I mean, philosophically, that's kind of a decision, right? Like that's more of a philosophical, people work in different, I am always the prototyper. Like I always just jump into code and start seeing, can I get something working?
Right.
And then I refine it back from there. That's not true of everybody. Not everybody likes that approach. I know a lot of people that like to start what you're talking about, where they define out clearly like how these objects are going to interact, what class structure and hierarchy there will be, and then they work backwards from that.
Yeah, but I think when you're a beginner and you're learning this stuff, just getting something going is one of those confidence boosters. right? It's like, you could sit and you can design a class hierarchy or an API on a piece of paper till proverbial cows come home, right? But you still haven't got anything running.
Very true.
Right now, okay, I haven't got anything running, but I've got stuff compiling, right? That works, right? It compiles on my machine. But yeah, just sitting there and just like starting to think through the process. So as I was doing this, I was like, okay, I'm going to start with this particular type, and it's going to need this and this and this, and as I went further in design, like, actually no, that's in the wrong place. This needs to go over here because of this that I've just discovered. So you'll see some of my thought processes as we go through that class hierarchy. And I wrote them up as like a series of questions and design considerations for things that I have yet to do.
What's really interesting too is as you're building something greenfield, right? As I say, or completely from scratch, no prior code existing. Something that just occurred to me too. One of the best pieces of advice that I got from one of my I used to work at startups. One of my first jobs working directly under the CTO of the startup, he told me, when you get into a large code base for the first time, you can pore over it for hours, right? But you really don't understand it until you turn it on. You get the engine running and you start seeing data flow through it, right?
Yeah.
So having some combination of both of those things, right? This kind of what we're calling on paper, diagramming, and also inspecting the code and also seeing it running, right? I think all of those things come together, right? And make it how you should approach writing software, especially if you're dealing with already, existing code base, right? Where you don't have full control over how things get implemented.
Yeah.
Hey, welcome, Veronica.
Veronica.
Welcome, Veronica, on a coding boot camp. Those are one of my best friends got into tech through coding boot camp. So very excited to hear you are taking that journey. So before we jump into your classes, let's talk about what we're going to be doing throughout the entire episode. So if anybody's watching, they know what's in store for them. They know, is this interesting to me? I'm going to stick around. Maybe I'll come back later. And feel free to jump in, and off the stream. Totally up to you.
Well, if I would say arguably that, if you're an experienced developer or you know some of this stuff and you're watching, don't necessarily tune out Beginner's Corner because we've got beginners watching this who have questions that either maybe we miss or we don't get to, that you can help them answer.
Yeah.
So, it's just one big community.
And we may be covering a language that you're unfamiliar with, even if you're advanced. But no, I wanted to just give everybody an idea of what we'll be covering. So we're going to start out with Steve's C#. Part 2, the continuation of an explanation of how classes and interfaces and static classes and things like that work in C#. We're going to then transition still in Beginner's Corner to getting started with TypeScript. So I'll talk a little bit about JavaScript, how it works, show you a few ways to get started really easily with it, and then tell you more about TypeScript and why it's important and how to get started with that. Then we're going to spend a lot of time probably today in Project Corner with some generative AI.
Most of our time today will be Project Corner. We have got quite an in-depth project to go through.
I'm super excited for this generative AI thing because I am not a machine learning. I would even not say I'm a machine learning novice, but I've discovered some really cool ways to get started with machine learning very easily, right? And spoiler alert too, they're all from AWS. So, but we will be getting and building something real in the second half of the show using the AWS CDK. So if you've ever heard of the CDK, you've been more interested in that, we'll be covering that. We're going to be using ECS and Fargate. So we're going to be Dockerizing a container or Dockerizing an application. Sorry, containerizing an application is really what I was
That's a bit meta, Dockerizing a container.
I know. Didn't mean to say that. So we will be containerizing and deploying an application to ECS. And then we're going to be adding in some generative AI through SageMaker. So we'll see.
So you tossed out a whole bunch of acronyms there, and a lot of people are like, "What?" So when we come back to Project Corner,
I'm explaining them all.
Explain what all those are. Yeah.
We got a great question. Are these videos saved, published? All questions are great questions from the chat, by the way. Yes, these are all immediately video on demand on whatever, on both Twitch and LinkedIn. If you're watching on LinkedIn, you can go back and check out previous episodes. Also, we also have a YouTube channel that I can come in and link, but I'm not sure if our previous episodes have been uploaded there yet.
I don't know. I know they're showing up on LinkedIn on the section there. So,
ooh, wow, this is that's a hard question to answer without getting into opinions, basically.
But it does tie into something that we've repeated in the past 2 episodes, right? When people have said, what language should I use first? And we've basically said, it's not necessarily the language, it's the type of language. So my recommendation, which still stands, is that you learn 2. You learn a strongly typed language like C# or Java, and you learn a dynamic language, a scripting language like Python or maybe JavaScript. I don't know. PowerShell, yay. So don't limit yourself to just one language. Look at a couple, right?
Yeah.
And you'll find that you'll gravitate naturally towards one anyway, as you gain more experience.
I'd say tangentially related question that I just had up there on screen. I don't know if you saw the question or not, Steve.
No.
Okay. So Daniela was asking for some beginner tips for like a software engineer, for a beginner software engineer. So this is actually kind of, I'll put the question back up because this is very interesting to me, because I took I'll call it a bifurcated approach to tech. We always talk about our backgrounds in each of these episodes, so apologies if you've already heard this, but I came to tech by way of a friend who I knew from high school, and he had moved into tech. I was an elementary school English teacher prior to that. And so I started learning on my own, right? Using resources and just building things in my free time. But then I ultimately went back and got a second college degree in computer science. And why I say this is interesting, what Danielle is saying about C programming, is I feel like a lot of college programs, I don't know if they still are doing this, but when I was going, they had me learn C++, which, to be honest with you, like in the career path that I've taken now, I have never used C++ in a professional setting. And I've never needed it because it's a much lower level programming language that you typically reserve for things like embedded software or things where performance is just incredibly important, right? If you're running it in an environment with very stringent like memory or CPU resources, you can utilize C++ or a language like C to get, the performance gains that you need out of it by managing memory yourself and doing these. So I learned all these concepts in college. And I think that's why college programs do this, is because it makes you learn concepts about memory allocation and memory management and things like that. But ultimately, like most professional programmers I know at this point are using something like Java or C#, where memory management, the lower level concepts that are present in C and C++ are not, they're handled for you through things like garbage collection.
It's an abstraction stack, right?
Yeah.
At the end of the day, right? You can code in raw assembler.
Right.
I have done.
You could do that too.
It's like putting together multi-thousand piece jigsaws. I love it, but haven't done that for a long, long time, right? Yeah. Then you have C, C++. I'm not going to go through all the languages, but as you're going further and further up the stack, you're abstracting yourself further and further from the machine hardware.
Right.
And the worries about doing things like memory allocations that you already mentioned, right?
Yeah.
Do we as programmers really need to care about that? What's the value out of us all learning how to allocate memory, right? The system can do that way more efficiently and track memory than we can, right?
Well, I think years ago, right, like decades ago, that wasn't true, right?
Yeah,
we didn't have that.
No, we didn't have these languages, right? I remember a time when things like Java didn't exist, right? So back then I was coding in things like C and C++.
Right. But the JVM is like an engineering marvel, in my opinion. And it has been built over the years by incredibly brilliant people to handle these very complicated things very well for you. And so this kind of is like, again, going back to the philosophy of programming in general, like at some point, you're going to be faced with a decision where you have to give up some control over something to enjoy an abstraction. It may be something like, my favorite example to use is like cryptographic security algorithms, right? So when you were generating public and private key infrastructure, for example, it is a well-regarded standard that you should never write your own implementation of any cryptographic algorithm, because they're very difficult. You're going to get it wrong. And this research has been completed by, PhD level geniuses that you can just take advantage of. So like, I take that concept and I apply it to other things, like you're saying, memory management, Steve. Like, do I really need to manage the memory in the environment that I'm running in? Unless I have a really good use case, why not use something like Java with the JVM that'll do it for me, right? Yeah. Or C#, right, with the CLR,
or
right?
Any managed runtime language, right? That does all this for you. Save yourself some effort. Focus on what. This sounds a bit glib, I know, but focus on the value add, right? Less on the I need to move these bytes around in memory over here because I'm running short over here. Don't care about that stuff.
I would say, though, like, understanding how that works and why it's there.
Well, yes, it does. It does help, right? Yeah. And this comes back to the concepts discussion, right? Learn the concepts.
Right.
That's probably the thing that stands you in better stead, right? Because I think I was going to make a statement. Most developers these days, I'm not sure most, but a lot of developers are polyglots, right? They can code in multiple languages, right? They have the scripting languages, they have the statically typed languages. I've been through, I don't know how many languages over my career, right? Yes. Learning a new language is actually easy, or relatively easy, once you know the concepts.
Yes.
Of the entire system, right? Which is why we're doing things like classes and inheritance and types and variables and things, right? That's the whole.
Not every language is a class-based, object-oriented language, though, Steve. That's some of the beauty of learning multiple languages is that you might, go look at a functional programming language like F#, right? That's not a class hierarchy object-oriented type language. I'm loving the conversation in chat right now too. We've got people talking about Java, more performant than Python, and that may or may not be true depending on some factors, right? Like, but generally speaking,
well, I'm glad you flagged that one up, because to me, it's the inverse. Java is easier for me to learn.
Yeah. Well, yes,
because it's an OO language, it's class based, and so on.
Or like C#.
Python, I can read it, but I don't necessarily fully understand it, right? It goes back to the underscore discussion that we had the other week, right? It's like, why have you got double underscores in there? That's weird, right? So, it depends on I think your back history a little bit as to where you've come from. If you've come from C-oriented languages, then Java is really easy to pick up, I think, as is C#. If you've come from shell scripting, right, maybe Python's easier and Java's a little bit harder.
Yeah. Got a very interesting question from Marie, and later on she talked about she learned Java while designing an Android app. But where is Java best used? That's kind of, neither one of us are Java experts, but I'd say there's a lot of Java web development, for example. Like I see a lot of web servers in Java, things like that. The whole premise with Java was write once, run anywhere, right? That was the whole tagline for Java when it came out. So anywhere that you could run the JVM, basically you could execute Java code. So, over the years, you've seen Java on televisions, you've seen Java on, like Marie said, Android devices. You've seen Java running everywhere, essentially. So it's hard to pin down and say what Java is best used for. What do you think, Steve?
Traditionally, I think most people think of it as what we call a server-side language, right? Writing back-end applications running on servers that some kind of a client communicates with.
Right.
I mean, it has been used for desktop
it has
development.
Yeah,
right?
Swing. Do you remember Swing?
Swing and all those libraries, right? So it has been used there. I don't think, well, again, I don't pay that much attention to the Java ecosystem. So I don't know really how popular it is on that kind of thing today. I think it's still very popular on the server side, but there's also obviously Android as well, because isn't that Java based?
It is, yeah.
So
that's what Marie said she learned Java for.
Right. So it still definitely has a role to play. Right.
I wanted to highlight this question too. Can we survive in IT with only PHP? I had an answer for this, my own opinion here. I don't think you can survive in IT with just one language, period. It doesn't matter if it's just PHP. I don't think you can survive and have a career in IT long term by only programming in one language. I think that will extremely limit.
That will limit your scope.
Where you can go, the jobs you can take. I think, as Steve said earlier, once you have fully learned one language, right, picking up another language becomes easier because you already know a lot of the concepts that, and this is what I do all the time when I'm learning new languages, is I think to other languages that I know and go, oh, this feature in this language reminds me of this feature in this language that I know. And you start making these neural path connections in your brain to things that you already understand and applying them to these concepts that maybe are hard to understand at first in a new language.
Yep.
Oh, look at this. We say this all the time, Steve.
Very true.
Yes. True. The best language to learn first is the one that just like you feel the easiest to pick up and learn. For a lot of people, that's Python because of how it's written. Like it looks very much like writing in like English language, basically. Yep. So it's easier for some people to pick up. Veronica asked about a 3.js library. I haven't looked at that yet, but I'll go check it out and maybe we can talk about it a little bit later.
COBOL developers. No, Chuck, I started as a COBOL developer.
Yeah, that's hey Chuck, how's it going? I haven't seen Chuck in a long time. Chuck's been a long time viewer of the AM and Nikki show back when it was me and Nikki, Steve.
Right. Yeah. I began my professional software career writing developer tools for COBOL developers in COBOL on PCs. So,
why
it's been a long road.
Steve, I think Chuck is making somewhat of a joke here because a lot of, I'd say, massive infrastructure, older companies are still running COBOL, right? And so
it's still a hugely popular language, right?
If you're a COBOL developer, you can find some extremely well-paying jobs because of how scarce the COBOL developer field is and how a lot of these older
I wouldn't
still
sneer at it.
No.
I've considered it a few times, I have to say.
Yeah.
But one of the things that was attractive to me back when I was a COBOL developer wasn't the language. It was the fact that downstairs in the building, there was a mainframe computer.
Yeah.
Which obviously requires substantial cooling. So in the summer, when it was hot in the office, because we didn't have air conditioning in the office, we would actually go down into the server room and just chill out in there. It was just fascinating.
Chuck is making reference back to Nikki. Nikki and I
was
built
the CEO, was she?
Well, we built a fake startup on one of our shows, and Nikki was the CEO of the startup because, of course, Nikki is the CEO. There was no chance of me being the CEO if Nikki's present. Nikki's doing really well. Still talk to her all the time. She's over at Meta, actually. Now she's at on the Instagram side. So anyway, miss her.
All right.
One more comment. Sorry, I keep pulling up the chats, but it's
that's
so
fine. No, we love the conversation. So
sure. It is very good to understand different languages. Can't agree more. Yep. Okay. So, Steve, shall we
jump in?
Yeah, we've got some fancy graphics now, don't we? Shall I play?
Somebody called me out earlier on for using phrases like something for everyone, but I can't help myself. We spared no expense on the graphics. So
that's right. Here we go. And welcome to Beginner's Corner.
We haven't gone very far.
Oh, Steve, that graphic, I love it. And you just got those today, didn't you?
Yes, I did.
love it.
Yes, I sent out a request and they came straight back. So,
All right, so we're starting with C#.
We're starting with C#, but we're only going to be here very briefly because we really want to focus in on TypeScript on this episode. But it was something I wanted to follow up from the last episode, which is still on LinkedIn Live. If you want to go and check it, we were looking at classes in C#, right? Because in C#, because in the very first episode we were looking at Python, right, and a scripting language and so on. And last episode we jumped into strongly typed languages with C#. And so we were defining, how to write classes, what classes meant. What are objects, etc. Right? But one of the things that we didn't really look at was any kind of class hierarchy development, which we're going to look at in a moment. And the other one was I was writing statements like new something, right? We didn't actually say what new was doing.
Right.
Like what's happening, right?
You might hear somebody say they're newing up an object too.
Right. I think I actually said that at the time, right? I'm newing up an instance of type, whatever. Right? It was like, we didn't really explain what's going on and how would you initialize that object, right?
I remember, Steve, when I was getting started, I would hear people drop this lingo all the time. And I'm like, what does that mean? And it's just one of those things you take for granted once you've been doing this for so long that newing is a word, and what does it mean? Like, let's explain it. Go for it.
Yeah. So let's just type up a class for a moment. So let's just say public class. I'm going to call it class A because I'm not very creative with my names, right? But we'll give it a couple of members and we'll say public int a number, right?
Oh, and you're in the C# REPL right now.
I'm in the REPL, yes. So I'm not using a compiler for this. I'm just typing in the REPL. It's called C# REPL. I talked about it in the last show and where you can go get hold of it. And let's give it a string as well, public string. And these publics just mean that the code that has a reference to an object that is of type A can access these members, right? There are different ways of doing it. You say protected, where only derived classes can see that member, and private, where it's private to that particular instance. So we're going to cover that very, very shortly. But just in case you're looking at this and wondering what's going on, let's call this a string. Okay. So I have a class.
Oh, we got a request to Zoom. Can you make it bigger?
Zoom? Oh, okay. Hang on. Let me up my font size. I thought I'd upped it up enough, but maybe not. Let's do it.
It is a bit long way challenging to see.
Is it? Okay. Let's go for 2028. All right. Hopefully that's
doing that. Veronica, I saw you're comment about 3JS. That sounds actually really interesting. Using WebGL to do 3D animated computer graphics in JavaScript. Very cool. There's a JavaScript library for everything. There's like a JavaScript library for robotics. It's everywhere. Right. It's amazing. Go ahead.
So we have our class, right? We have our template for an object, which is what we said it was last time, right? It has some properties, some members, some variables in it, right? A number, right? And we're going to instantiate A. We say var A equals new A, right? Great. We have an object, right?
But these variables that you put into that class are special variables. They're different. Like you don't have to say public when you declare a variable normally. Oh, it's null. Interesting.
It's null, right? Because it's a reference type, so it initializes to null.
Right.
Now, what happens if we want to actually control the initialization of those fields, right?
Yeah.
Inside the class. So we can actually write something called a constructor. Right. There are a couple of ways of doing this. We can also initialize the property inline. We're going to see it again very shortly in the class hierarchy. But we can actually put a constructor in. So let me redefine A again, and this time we'll say public A. Right. And this is how we define a constructor. We give it the same name as the type in C#. Right. Some languages have a different convention, but it's the same name in C# as the type. And then we just give it some variables. So let's call public A int. Actually, let's give it a default constructor. What we call the default constructor, right? It's not going to do anything. Right? So if I instantiate now, say var A1, let's have a new variable equals new A. What's happening here is that default constructor that I just defined in here, public A, just got called. Now you can ask yourself now, well, what's the difference between that and this version where there wasn't one, right? Here I've been explicit and given it a constructor. This allows me to actually control the initialization of the class. So
Right.
what you would typically do is something like this. So let's say we pass in int I, some kind of a value, right? And string z, right? And we'll say, let's say that a number equals I, and a string. I really should have better naming. I know.
I didn't want to say anything, Steve.
All right. Okay. So now to have our a2 equals new a. You'll notice now there's an error.
Uh-oh.
Because I've overridden the constructors for the class, for the type. Right.
That's
so
right.
that default constructor that the compiler gave me all the way back here no longer exists. Right? In fact, all the way back here as well. Right.
Right.
Now I've been explicit. I've said this object has to be constructed with using the constructor passing two variables, right?
Integers. Yeah.
Two variables, right? So let's do it properly. We'll go var a3 equals new a, and let's give it, I don't know, 100 and hello world.
Well, see, this is interesting too, because like in JavaScript, you know, it doesn't matter. You can, you know, you typed the parameters for that constructor, by the way. Like, you can't do that in JavaScript. JavaScript,
right.
You just pass whatever in there and hope that you did it right. Which is why we'll see TypeScript adds in some of this functionality that we're seeing here.
There's a great question from Michael that's just popped up in the chat.
Yeah.
Can you throw it on screen?
You got it.
Right. So here's how. So you need to go back to the last episode. But what's basically happening is the number, the integer, is what we call a value type in C#. And that always initializes to 0. String is a reference type.
That's right.
But they always initialize to null. Okay, so they're two different types. So it's kind of in a little bit of a, it looks like a class hierarchy. It's really not. We have some resources for C# that we can throw up at the end that explain the difference between value types and reference types. But that's ultimately the difference as to why one initializes to 0 and one initializes to null, and not just an empty string. Because in some languages, a string that you don't assign a value to is automatically an empty string. That's not the case in C#. Okay.
Yes.
So now, if I access these values, you should see that they've been initialized. Okay. If we use the string, oops.
Got Marie saying that the error message is too formal. It'd be better if
There's
they
no
made
argument given.
funny.
Yes.
I agree up until the point where I'm at, you know, debugging at 3 a.m. and I'm getting some funny messages and I'm not laughing anymore because I just want the thing to work. But no, that would be fun to have some funny messages in there.
Now, what's interesting is that you can also do things like this. Let me see if I can get back to my original definition of A. And bear with me while I just push this through. Actually, I want to go back further than that one. So I'm going to get back to A here where I made this public constructor. So I'm going to rename this to B. Again, I'm not very creative with my class names. I know. Right, B. I'm trying to avoid typing because I have a little bit of carpal issue in the wrist today. So
you didn't even go to you went straight to B. Not even like, oh, let's do Z, you know, or M.
I did see earlier on.
Okay. You're going in order.
Now look what I've done. I've taken the access modifier public off the constructor for B.
Oh, interesting. Okay.
Right.
And like I said, these are referred to in C# as properties on the class. They're just like
these are typically these are fields.
Okay, fields.
Properties have getters and setters on them. There's a slightly different syntax, but these are fields that I've just made directly accessible. I'll show you a property in a bit, right?
Okay.
Now I can't instantiate B anymore. Remember earlier on when I had A and I didn't actually have a constructor in there at all? I was able to just new A. Everything just worked fine. Now, because I've overridden that constructor, the parameterless constructor, as we call it, I can't actually instantiate it. Now, why would you want to do this? You may be asking yourself. There is an argument out there where I think 50% of the developer community would say that constructors should never throw exceptions.
Yeah.
Right. So an exception is something's gone wrong and you throw something called an exception that says, hey, there's an error. I can't go any further. Right. And the outer code is supposed to catch that exception and then do something with it. Or if it doesn't catch it, it bubbles all the way up to the top of the program and the program just crashes.
Yeah.
Okay. If you have an object that needs some complex initialization,
like an asynchronous call,
right, or something, he needs to call a web service to get some value, whatever, right? You wouldn't put that in a constructor because that could potentially fail, right?
Or so you can't mark a constructor asynchronous, can you? In
no.
C#? Yeah.
I don't believe you can anyway. I've never tried. I don't believe you can.
I don't think so.
So what you would do instead, you would move that initialization into a method, into what we call a factory method on the object, right? Which is typically static. In other words, there's only one copy of that method, but it gives back a new object of that type, which I'm going to show you very, very shortly, right? So it's a common coding pattern that you will find where people will mark the constructor either protected or private, right? So that you can't just new it up from external code. You have to go through a certain method to create an object of that type.
Yes.
Right.
Yeah. I would say maybe another use case for this would be like if your class has like a composition style,
right.
you have to instantiate a bunch of classes to actually constitute this class.
I'm glad you mentioned that because that's exactly what I'm doing in the game.
Look at that. It's like I got your back, Steve.
Got me back. All right, let me jump into some type examples because this will explain a little bit further what's going on. So
okay. Now we're in JetBrains.
Now we're in Rider. Yeah. Hang on. Is the font good? Probably not.
No.
This is the peril of changing your font every time after you do a show. General. Here we go. Font size. Let's go for 24. I thought that was 240 for a moment. Is that a little bit read? I can read that. Is that good?
Yeah, I think so.
Okay.
If it's not, let us know in chat, please.
All right. So here we're actually inside an IDE, JetBrains Rider, right, for C#. And what I've done here is I've just got my little class A, right, and I've got some members in it. So this one, for example, here is marked private. So access to that variable, that field, can only be done within instances of A.
Right.
Okay. If I have a derived class, B derives from A, which you're going to see, it can't access that member because it's marked private. So if I want B to be able to access that member, I have to mark it protected. Now, protected means derived classes can access that member, but external code cannot. Right? It's not public. It has to be public, right? These two fields can be accessed by anyone. Derived classes, the object itself, external code. So when you're looking at class hierarchies in a lot of C-type languages, you'll see these members: private, protected, public. C# has another one called internal. So you can mark something protected internal, which means it can only be accessed by code inside the same module,
file,
right?
Or
DLL.
Namespace.
Yeah, no, not namespace, but module. So DLL,
okay.
Dynamic Link Library. Right?
Got it.
It can't be accessed externally, right?
Let me ask you this, Steve. So, like that field _a number, when you instantiate a new class of A, since it's public, you can actually assign a new value to that regardless.
This one?
For those, yes.
Yes.
But for the protected and private, even on the same object itself, like that you instantiate, any protected or private field, you can't change those values, correct?
Right. Okay. Right. Yes, you definitely can't change this. A derived class can't change that one, rather, because the derived class could change that one.
Right.
Right, because it has access to it. Right. So let's talk about these initializers. What you'll see is here I've got these things like equals 10, equals 20. What's going on here? But remember I just showed you the constructor where I passed initial values in. What this lets me do is initialize members or fields to values. Instead of getting that 0 and the null that I had originally when I didn't have any constructor, this allows me to set values immediately on object creation, even if I don't override the constructor.
Okay.
Okay. So I'll get a default value of 10 for only visible to A, 20 for another int, and so on, right? If I want to write a constructor that changes those values, passes them in like I just did, I'm perfectly able to do that, right? But this gives me that initial value. So back to the question about why was the integer type initialized to 0 and the string type to null? This would allow me to work around that. I can actually assign a default value, string.empty, to the string member if I want, instead of null, right? So we have some other things in here that you might not have seen before. So static, what does that mean? Well, that means there's
Static.
only one copy of that method. It doesn't matter how many instances of type A I have, there's only one copy of that method.
It also means that you don't have to instantiate an instance of the class to use that method.
Access it. Correct. So if we go into my little program here, you'll notice right at the very top, I can access public static member without actually instantiating the type. I don't need to do new A and then call the method. I can just call it directly.
Right.
But there's a flip side to this. You can't call a static method if it's protected.
Interesting.
Right. And this I didn't know until this morning when I tried it. I thought, oh,
yeah.
Right. And that's where you have to do something like, let me get the method here, which was the static.
I wonder why you would need a protected static method then.
Indeed. Well, you would.
Maybe inside of a class.
Well, if I only want derived classes can see it.
Right.
Right.
So the derived class could call it.
If I do this, protected internal.
Wow.
Now this can be called.
Oh, okay.
It's not something I've ever done a lot of, but you know. So here's where I was calling a constructor, even though I didn't actually have it on A. There is no constructor defined, right? The compiler's giving me one.
That's right.
Okay. It doesn't initialize anything in the code, right? I'm using the actual initializers.
Got a question about static from chat.
Static in both local and global. I'm not quite sure what you mean by local and global, Marie. Can you just clarify?
Maybe.
Scope, maybe.
Yeah, a lot of languages have especially like JavaScript. JavaScript has this idea of global scope, which is like basically anything outside. Hard to define global scope.
So global scope would be like this.
Yeah. Yes.
Right. So correct. Yes. So inside A, here's an instance method. Okay.
Yeah.
And I can't quite remember. And I call a static member from an instance. Oh, here's one where you can't call a static member using an instance. So this is global scope, so you can't call that static member, right?
Or you can't call it off of the instance. You still have to call it.
Let's see if we can do this. I don't know. Let's try it.
Like a nested
equals get an integer value. Yellow.
You should.
You'll notice there's no squiggles, so that answers the question. Yes, you can. Yeah. Right. So inside the type, I can call a static member, but externally,
I'm surprised you didn't have to use the class name or like a keyword like this. Or
you're inside the class.
That's true.
The compiler knows the scope that you're in. So, this is an example of calling a base type. So let's go back to the class hierarchy, and you'll see that if I jump down here, I have a couple of other classes. So class B.
We got another question about static.
What is that different? Protected internal static and just protected. So protected internal static, there's only one copy of that method. Okay, shared by all instances. Protected without the static is a different method instance, is a different method across all instances. Same code, but is a different. It's like having a copy of the code, effectively, is the best way maybe I can explain it. So static, you can think of all objects of type A, all sharing the same method. Whereas if I just mark it static, I have all objects of A, and they all have their own little copy of that method. Right? That's the way I think about it. So here's B, and you'll notice I have this funny little colon A syntax. That means derived from A.
Okay.
So B is also of type A, right? I can cast it upwards and say, hey, treat this as like it's A, right? But you can say I'm adding methods to it. Now, here's a property. We were talking about fields earlier on and properties, right? So here's a property. So instead of having those directly accessible fields, like a number and a string, I can put them behind a property. Now, this is a simple value, right? But in C#, I can do something like this, which is something I used to do a lot. I can actually write some code inside here to do something with that value, right?
So now we're dealing with a property because it's got the getter and setter.
Right. Yeah. So write some code here. These are like little mini methods that are attached to properties.
Right.
The backing variable.
And they get called automatically by the.
So inside my code, if I say some value equals 10.
Right.
The set is called.
Right. And if I do the dot method off of the class instance.
If I call, if I access the value of some value, the get is called.
Right.
Now it means I can have code that runs when I get a value.
Yes.
Maybe it has to make a call somewhere, right?
Or it needs to compute that
or it needs
value,
to compute
right?
something, right? That's how you would do it, right? Let's see. We'll go a little bit further down. I don't think I put any methods in C. So C is just an empty class from D, from A, sorry. And then we have D, which derives from B. So now I have a variance in the class hierarchy. I've got A, B, C, A, B, D, right?
Okay.
Notice that the derived class D cannot access the private member in A, right? That's not allowed. That's what private means. But derived types can see protected members. So when you're going through class hierarchies, when you're looking at code, you're going to see this an awful lot, right? Public, private. Obviously, one of the best approaches I've seen, and something I always tried to keep to, was all of my fields were always private.
Yeah.
In my classes, right? Never provide access to them. Either give access via a method, which means you can change the value, the type of that field without without code that's calling it knowing, right? So let's say I have a field that's an integer, right? And I want it to be a string in a future version, right? If I expose that field directly, all that code that's compiling against it now has to change.
Yeah.
If I expose it behind a property or a method, I can safely change the backing type.
Yes.
And then convert or coerce the value to be what I need it to be.
Right? It makes you be explicit about handling state in your class.
Yes. Yes.
And the other thing too that you're describing, Steve, is actually very important across, I'd say, multiple different facets of programming. You're thinking about the consumer of your library, right? You're thinking about the person who is going to have to use the classes, the methods, the properties, etc., of the code that you're writing. Because if you're the only consumer, maybe you could be a little bit lax, but that's very rarely the case, right?
Yes.
You are almost always writing something that somebody will consume. This extends out to when you're building a REST API too, right?
Yes,
same concept. Right?
Yes, right. You have to try and think about how are you going to version that API?
Yeah.
Right. Are you going to just say, oh, hey, you can't call this API method anymore. We're going to delete it.
Right.
Now what happens to all those consumers, right? So
they all break and they get really upset with you when their stuff stops working.
Yeah. And here's an example of, we just saw a constructor right in the REPL, but here's a case where the constructor is actually setting a value in the base type.
Right.
Right. And one of the things you'll sometimes see in code as well is something like this. Base. And what that means is before the constructor runs, before D's constructor runs, it will call the constructor for B.
Oh, okay.
Right? And you can pass on a value. Let's say that B, where is B?
We've got a keyword in TypeScript for this called super.
Yes, super. You'll see that in some languages, right? So let's say we have public B. I don't know. Let's say takes a string, right? I don't know what I'm going to do with it, but let's just say we have one, right? A, B, C, D. Is everybody confused yet?
Absolutely.
Right. But now look, when I call base, I have to provide a value.
Got it. Okay.
Right. So what you'll commonly see is like you'll have base classes that have a set of properties in them or fields, right? The derived type you'll call new with additional values. And then the subset of values that belong to the base will be passed up by using this syntax, base, pass them up. I'm going to show you right now, right? And then you'll initialize the value you need from the constructor in D's constructor.
Okay.
So enough messing around with that. Let's go and look at a real hierarchy with some actual names in it. So this is, I've called it Anopoly because I don't want to get sued for trademarks. All right. And
that's like the Ouija board instead of the Ouija board.
Yes.
That's also a trademark. Did you know that Ouija is a trademark term, Steve?
I didn't, but I do now.
It's Milton Bradley, I believe, a trademark.
So
maybe Hasbro.
This is a .NET console application that, and again, the discussion we had earlier on about modeling something for real and then actually just getting some code running gives you confidence. Is, having got this class hierarchy together now, I'm getting more and more, let's say, invested in it.
I see a static method right off the bat.
You see a static method right up here, right?
Yeah. So
all my code, my program consists of is basically initialize the game, right? We'll see what that's going to do in a second. 4 is the number of players. and then run the game loop. Right now, game.run isn't implemented yet, right? So we're not going to run it today, but I want to show you the class hierarchy. So let's start at game. And this is the composition I went through in my head as I was putting this together, right?
I know you hate when I interrupt, but like that's actually a really interesting point, I think, that I don't want you to miss. You just said game.run isn't implemented yet. But you're already thinking about it, right?
I'm thinking about it, yes.
You have already just determined out in your head, I want this game to start by writing a method called run, right? And I'm going to write that function later, but like I'm going to put it in code right here so that I can start defining out how my program works.
Yeah, I mean, I could have done things like, put the game loop here, right?
Right.
And not done this.
Right.
There's a game loop, right? A die is thrown, player moves, something happens, the next player has their turn, right? That's the game loop, right? Until someone wins, right? I could have done that there, but it's just cleaner. This
is you designing, is what I'm saying. This is like you actually designing out the program. And I don't think that's readily apparent to people who are just getting started that like this is how programmers work. They actually
sometimes
will like throw out a method, and then write the method later. But as they're designing it, they go, oh, I think it would make sense to have game.run here.
So there's 4 principal things in a game of Anopoly, right? We've got the game itself, right? An instance of the game that's running, right? So if I actually go and get my game board over here, because I literally do have,
oh wow,
right here, Monopoly game board and so on, right? This is what I've been using. Remember what I said about modeling something in the house that's real?
Yeah.
I really found it helpful to just have this on my desk with the board out, going through, figuring this out, right?
Now you're absolutely getting sued because you just pulled that out and said, look, this is what I based it on. You're gonna have to like lean into parody law, Steve, and just say that you're making a parody of Monopoly, like Weird Al or something.
Right. So we have a game. We have a concept of a game, right? That's running. A number of players are running a game, right? That game has a board, obviously has a number of players, right? And there's a bank, right, which is doing all the transactions. Okay. So here's my assets. So I have a game. Let me open this one up. And you can see here, I've got some private members, the minimum and maximum number of players, right? I just showed you private accessors, right? I have a read-only list of players. Now, this is an interface, which we're going to come to in a future episode, right? Because one thing I forgot to mention when we were talking about class hierarchies, remember when I went in the hierarchy from A, B, C, A, B, D, right?
Right.
C# is single inheritance. You will sometimes find multiple inheritance thrown around, right? Typically, if you use C++, that gets really mind-bendy in my experience. It does have its uses, but mind-bendy. The way we kind of convey not multiple inheritance, but multiple behavior in C# is we use interfaces. So we have a base class, 0 or more, and we have 1 or more interfaces.
Yeah,
I can attach as many interfaces to a class as I like, right? And we'll cover that in a future episode. But when you see something that's prefixed with I, typically that means it's an interface. It's a collection of methods that the class that says, oh, I support interface I this has to implement.
Yes. That's not strictly enforced, by the way. The I read only.
No, it's not, but it's convention. It's coding by convention.
Yes.
Right?
You may run into interfaces if the person's not following conventions that don't start with I.
So you'll see that we have a bank, right? We have a game board, right? Notice these are all private. These don't have no scope outside of the game, right? So why would I give access to anything else, right? So I mark them all private. And here is my static initialize game method that returns an instance of type game.
Yes.
Inside the game, I do here's a case where I'm going to throw an exception. If you tell me I want a game of 10 players, that's not valid. So here I'm going to throw an exception, right? Instead of doing it in a constructor.
Okay.
Then I'm going to create my board. And again, I'm using a static initializer to initialize the board. I'll show you why in a second. I then have a little loop that constructs a list of players.
Are you making a singleton, Steve?
Yeah, game is technically a singleton, yes.
No, I mean on the board. Is that
the board is also a singleton, yes, because you can't have multiple boards in a game. There's only one, right?
Singleton. It's a pattern for when you use the code to control how many of the instances that you're allowed to actually instantiate.
Yeah, in this case,
it's only one.
Right. So once I've got my players assigned, then I initialize the bank with the positions on the game board. Now, you might think, what's he doing that for? Well, positions on the board are either properties, utilities, stations, or they're special spaces like jail, right? Well, some of them are owned or are ownable. Some of them are not, right?
Yeah.
So I'm transferring ownership, if you like, of all the unpurchased properties to the bank to start with. I'll show you that code in a minute, right? Okay. And then I simply return a new game with the players, the game board, and the bank. So here I'm calling a constructor, and here is the constructor. You'll see it's marked private, right? Because I want to force construction or initialization through that static member. And then here is my run loop.
Oh, there it is.
Be implemented, right?
To do,
right? A player right now doesn't have much in it. They just have their token, right?
Okay.
I think the old tokens were boots and iron. This is from a more modern version of the game. Where they are on the board. Now, this is as yet unimplemented because I'm still thinking through who owns the player's position on the board. Does the board own it?
Or does the game?
Or does the player own it? Or does the game own it, right? How much money they have available, right? You'll notice that anyone can access their money, but only they can change it. Only the player instance can change it, right?
Oh, interesting. Okay.
The list of properties that they currently own, which is just a get, right?
Yeah.
Then we have the constructor, where they are, etc. A couple of methods for taking ownership, reducing funds. Yes, it's simplistic. This will be transactional in the real world, but simplistic, right? And so on. Then we have the board itself. And on the board, we have a list of positions, right? These are all the positions around the board. Then we have the bank, and the bank has probably most methods of everything so far. So the bank has how much, we have some constants for the cash that players get, whether a property has been mortgaged or not, the list of remaining ownable properties on the board.
Okay.
And so on. So all of this is building out in my head as I'm going through this. Now, how does this board position thing work? Well, here's where we get into the class hierarchy. So a board has a number of positions around it. Okay. But it doesn't make sense to instantiate a board position.
Yeah.
Right. It has to be either a property, a utility, a station, or one of the special positions. So I've marked this class abstract. So you can't new board position. Makes no sense.
Only inherit from it.
Only inherit from it. All properties have a name, and they have, well, in fact, we construct it using that, right?
Oh, I could ask you a real tough question here, Steve.
Go on.
Would probably we go down a rabbit hole here, but I'll ask it anyway. Why would you use an abstract class instead of an interface?
I could use an interface. That's the point we're going to come to at some future episode.
Okay.
When I started this, we hadn't actually defined or even spoken about interfaces.
Right.
So I'm keeping it as a class hierarchy.
Okay.
In a future revision, when we talk about interfaces, I may switch this to be an interface-based approach.
You might use something like dependency injection with those interfaces.
Potentially. I don't know yet. But this is, for now, is just a pure class hierarchy, right?
All right. But we'll talk about that when we talk about interfaces.
Yeah. So when we think about properties around the board, we have the concept of ownable properties, properties themselves, streets,
yes,
utilities, stations. And we have unownable properties like community chest, chance, jail, go, right? So then I further distinguish them. So an ownable property derives from board position, right? And we have the street colors, brown, blue, pink, orange, etc. They're all in a group, right? Which group does this belong to?
Oh, I saw bank. Was the var name the same as the type name?
I'll show you in a sec. Yes, the property. Yeah, you can. Yes, C# can do that. Yes. Okay. Yeah, I think you saw. I think you're referring to this one.
Yeah. That's
yes, C# can distinguish the two, so that's okay. I mean,
Maria's asking you to run the code, but it doesn't run yet.
The code doesn't run. There's no game loop yet.
Not yet.
We're still working our way through the mental decomposition of the hierarchy. So then, obviously, each property has a purchase price, right? Then we have things like actual properties, like a street, which is an ownable property, right? Has a name, a group, what group it belongs to, its initial purchase price. We have unownable. We have utility properties. Now, why have I got these as separate things? Because the rent is computed differently depending on how many properties of these you own.
Right.
So behavior is starting to come into the class decomposition now.
It's like a modifier, right? Like,
right. Similarly here, we have station. If you own all 4 stations, right, the rent goes up. We have jail. We have go to jail. Right?
uh-oh.
These all have behavior. For each
Got,
player, we're instantiating a bank. Why? No, we don't have a bank for each player. We only have one bank.
only one bank.
So there is only one bank in the game, which is instantiated in the initialized game static. So bank here.
So the game object is
the game owns the bank. Yes.
Yes. Right? Yeah.
The player can have a reference to the bank, but it doesn't have its own bank.
Mm-hmm.
I think maybe thinking about the funds here, right?
Right.
Okay. So, and then obviously we have things like chance and community chess. So we have this class hierarchy. A board position is, an ownable property or something special, chance, community, etc. And then ownable decomposes into stations, utilities, and streets.
Okay? I also could throw in here, Steve. This is where people differ as developers, and this is not actually part of the language choices or anything. Well, is a language choice, the English language choice here. When you say board position, see, when I first saw that class, I thought you were describing where the player was at on the board, and you were tracking like coordinates basically in that class.
Right.
So this is why naming things in programming is very important, right?
And very hard.
And very difficult too. Yes, exactly.
Yeah. Now the board itself, I have not yet decided who owns the player position. I think it's going to be in the player itself. You'll see here that they currently have their own position.
Yeah. So the board position, right? Actually referring to the properties, the utilities, and the special.
Yeah, it's where they are
on the board.
Got it. So in the board here, you can see at the top here, I'm using an initialization of the list here.
Yeah.
And here are all of those properties all being initialized with their own little constructors, you'll see.
Yeah,
right? It's going to take a name, their grouping, their purchase price, other than just...
This is the composition we were talking about earlier.
Yeah. So game is composed of a board, a bank, and some players.
Okay.
Right. A board itself is composed of a number of positions around the board. Right?
Yeah.
So you can imagine now that a player moving, right?
Yeah.
In that game loop. This is where I got to yesterday, where I put it to one side. Is okay. Let's think about the game loop, right?
Yeah.
So a player rolls the die, right? They get a number. Now they need to move.
Okay.
Right. So they can go to the board and say, well, here's where I am. Here's the number I got. What's my next position? Right. So that's the method that I'm starting to write out now that understands the idea of like, okay, if I'm here, if I'm here, right, the last street on the board, and I roll 6, I have to come back around, go, and then down 5, right? Yeah. So I don't want people accessing this list directly. So I will encode all of that behavior into a method on the board and say, player X roll this value, return their next board position.
What a wild coincidence. All of these properties are places in London.
The classics, right?
Yeah.
But while I was doing all of this, as I mentioned earlier on, some questions and design considerations started to come out. For example, like I just mentioned, how do we record where a player is at the board? These were things that occurred to me as I was composing the class hierarchy.
Right.
Right. So rather than try and solve the problem at the point that it occurred to me, I just make notes. Right. And then I will cycle through these notes and make a decision about, oh, actually, this is the best place to put that code, or I may move it. I've already moved some of the other options around on the board game rather. How do we test our positions available to purchase? Well, we have the bank own a collection of purchasable properties, ownable properties, right? And when a property is purchased, we give it to the player.
Chuck's
right?
answering.
All position players all begin in go. Yeah. So if you look at board, right? I think board has a member on it. There we go, called player starting position, which returns a board position object which maps to element 0 in that list, which is go. Nice. So instead of recording an index of 0 into each player, I do this.
Okay.
Anyway, back to the game very briefly, because I know we want to dive into
yeah, you're taking up all my time, buddy.
I am taking up all your time, yeah. But this is fascinating. Right? As you start to dive into this.
If you say so. No, I'm just kidding. It is.
I am so invested in this now. I am going to make this run. So yeah, next Code Corner, you're going to see this code actually running and a game actually go. Aim and I are going to play a game. It may not have all the rules encoded yet, but we are actually going to play this game.
Can I ask the most important question?
Yep.
Is this code going in our Git repo?
It could do. I have no objection to it doing so.
Okay.
So
right.
Yes. So other questions like, recording the properties a player's purchased. How do we record properties that a player has remortgaged back to the bank in order to get some funds, right? And there are some rules around that process. If you read the actual game rules, right?
Yeah.
How do we track a player's in jail versus just visiting, right? Who owns rolling the die? There's a good question, right? Who owns rolling the die? Does the player own it? Does the game own it? To be decided, right? There's some auction rules. There's a whole bunch of things. When you start to read the game rules, there's real subtleties in there that start to affect how you design this class hierarchy, right? So that's where we're at with Anopoly and C#. But you saw the whole bunch of techniques used that I just showed you, right? Using constructors on classes, using factory methods to initialize, where we're using a composition model, and so on and so forth. So are there NPCs? What's an NPC?
Non-player character.
Non-player characters.
They're like a robot, that could play against us.
I see what you mean. Yeah. You know what? That's a really cool idea.
Isn't it? What? Oh, look, you've added number 30 to Steve's short list of features.
I was going to say, are there any NPCs? Player characters.
Oh, here you go. This reminds.
Would you like to play a game? Yeah, that's exactly where this is coming from.
One of their first exercise in C#.
So there's some C#. We've shown construction, initialization, different ways of initializing things. Next time out, we'll take a look at the game loop and probably the finished class hierarchy at that point.
Okay.
At least enough to support an initial game loop. And yeah, we'll go from there. But again, I want to stress this: if you're learning a language and it has a kind of a hierarchy, the type hierarchy in it, go and find something in your home or your environment that you can model. Furniture, things in a room, something physical that you can actually look at.
Make a list of 30 items.
Make a list of 30 items that you want to satisfy, right? And have a go at designing a class hierarchy that represents that.
Yeah.
Right. And think about, who needs to access what data? Where should that data live? Where should the behavior be? And you'll find that, I think, personally, I know I do, you'll find that to be useful. So with that, I suggest that we move on to your part of Beginner's Corner, which is going to be very, very brief.
Yeah, it sure is now, isn't it?
You got 45 minutes, dude.
Wow. Okay. Let me show a picture of Steve. I've actually got a picture of Steve as he was designing Anopoly. It's right here. This was Steve writing down all of the 30 plus features.
I didn't write all 30 down in one hit. I have to admit, it occurred to me over several days as I was composing that hierarchy. So, but yes, so check back next time for the next installation of Anopoly.
Look, you've hit something special for Marie here. They're learning with making games. Chuck says, got to run. Thanks for joining us, Chuck. Really great to see you after all of these years. I mean, I think I first started seeing talking with Chuck 4 years ago, Steve. It's got to be 4 years ago now. It's pretty wild. Thank you, Marie. It's about to get even more fun,
as my grandson would say.
Okay, so
Bam, you're going to have to increase that font. I'm sorry.
Oh yeah, no, we're not starting in the playground. We're gonna be I'm gonna make my own local. I actually already have a local playground. Yeah, I sure do. I always one of the conventions that I have. So number one, I'm always curious about how people organize their development folders on their computers. What I do is I have a lot of languages that I work with. So I have like named folders for each language, and then I have projects under those languages. One of the conventions I always use too is I always have a playground folder in my language so that I can just go and like write some quick stuff and be able to run it outside of like a larger project that I'm running. Anyway, so I am going to use, Steve was using, let's see, he was using, I got a bunch of open things, and I should probably make my own different playground here. So let's see, I will actually. I'm going to make code corner playground. This is just a directory.
Okay.
To organize my code. But we're going to talk about a couple things today. We're going to talk about JavaScript, and then we're going to talk about TypeScript and what the differences are. And I've got like probably 15 minutes to do that so that we can actually start coding up the...
I'm sorry, I am.
Are you? Are you sorry?
No, not really.
Okay, well, all right. So let's just start, just like you did, Steve, with a REPL.
Uh-huh.
A REPL.
What's a REPL?
It's a read, evaluate, loop, print, right? No, print loop. Sorry, I got discombobulated in my brain place. So it takes in code, it evaluates the code immediately, and then prints it out, and then starts back over again, right? So you can do everybody's favorite. You got to start, right?
You got to start with hello world, yeah.
Nope. Hello chat.
Oh, you're doing hello chat.
Gotta pander to the audience, buddy. Come on. You got to keep them on your side. Hello chat.
Okay.
So console.log, that should look familiar kind of to you, coming from C#.
Yeah,
it is also
console.writeline. Yeah.
Console.writeline, right? So this is for input, output, right? What else do we want to talk about in some JavaScript? You want to look at some variables?
Yeah. What do variables look like?
All right. So we'll make a string. What should we make? Quote. How about that? You miss 100% of the shots you don't take. That's Wayne Gretzky, Michael Scott.
Okay. So whereas C# used var,
yeah,
here you're using, actually you're not defining the type, right? You're just using assignment. That makes me curious of why you need let and equals, but I guess that's just a JavaScript thing.
So let is a keyword that allows you to, I'll show you actually. How about I just show you?
All right.
Quote to, look at me naming things like Steve. No,
you got too many letters in that. It should be Q2.
What's our next quote?
You're going to need a bigger boat.
Oh, that's a great quote. A little Jaws for you. Need a bigger boat. Okay. So again, I can just type out quote again and see it. What if I wanted to change our first quote to actually be our second quote? I can do that. So now quote and quote two, they're both the same thing. What if I wanted to change quote two though?
That shouldn't be allowed.
Oh, you can't.
Nice.
You can't. So let and const are two different variable assignment types in JavaScript.
Okay.
Const means I can't change that value ever again, basically. And let means, yeah, I can reassign. So we can take quote one now and we can actually make it to a number, which just like we saw in Python, there are no defined types in variable assignment when it comes to JavaScript. You can assign.
We saw in last month's episode, you can't do that in C#.
Correct.
Right?
Yeah.
Without
that's right.
doing some kind of parsing or conversion.
Yes.
You can't just directly assign a number to a string.
Right. The compile time will not let you do that. The runtime often will throw an error depending on what. So if I had I think that quote is a string and I do something like try and take a property off of a string value, it's not going to be there. Or if I try to lower case, for example, on quote, that's going to throw an error because quote is no longer a string, right?
Right. But this feels to me like we're looking at type unsafety, right? There was nothing stopping me writing that code in JavaScript and deploying it to production.
Right.
On my web page, right? And then my web page is just blown up.
Correct.
Right?
That's right.
So is that where TypeScript comes in?
Yes. So TypeScript gives you a lot of the functionality that we saw over in C# on JavaScript, right? Where JavaScript doesn't have it naturally in the language, right? It doesn't actually exist in the language. You can't assign the type and enforce that type on variables, right? It just doesn't work. As we saw, we could change it to whatever variable type you wanted,
right? Yeah.
I can reassign quote to a function if I wanted to. I'll show you that actually. Some interesting syntax here too, right? And then I'll enter to the chat again. All right, so now quote is a function. So I could actually run quote as a function. It's crazy, right? Like you just assign
totally crazy.
Whatever you want to whatever you want. Pretty wild. But I like it. It's very it fits my lifestyle.
It sends a shiver down my spine. But anyway, that's beside the point.
Look, Steve, I live on the edge at all times.
Yeah, I can tell. I like my types well defined. Thank you.
Everybody's got a plan till you get punched in the face. Another quote for you. I don't know who said that quote actually, but anyway, TypeScript will let us take these types of things and get rid of them from the language. However, something that's interesting to know, Steve, is that TypeScript doesn't really exist as a language.
Right. It's not a compiler and it's not a language, right?
Well, it's not a language in the sense that you can't run TypeScript.
Right.
You have to transpile. Somebody in chat said this earlier when we were talking about TypeScript. You have to transpile TypeScript into JavaScript because all of the engines that accept, the JavaScript runtime, there's Node.js, there's browsers, et cetera, they can't run TypeScript. It doesn't exist as a language. It's not a runtime. It is a basically syntactic. You called it syntactic sugar earlier, right? Yes. What does that term mean?
It's syntax that lets you express stuff more conveniently.
Yeah.
So I'm trying to think of something in C#. There's a lot of syntactic sugar in C# actually. And interestingly, the inventor of TypeScript is also the inventor of C#.
Yeah, we didn't mention that yet.
You see a lot of this interplay between these two languages. Right. Properties, right? The properties I showed you, that's really just syntactic sugar for a variable with some code attached to it.
Yes.
What else was syntactic sugar? It'll come to me in a bit. I'll randomly throw some syntactic sugar at you.
All right. So now I've moved into
So now we're in TypeScript, right? Because you got that .ts on the file.
Exactly what I was about to say. And so I am declaring out that quote cannot be anything but a string, right? So if I come in and try what I tried earlier, the universal.
You got squiggles.
Oh, well, it's actually squiggling for a different reason. Let's change it there.
But you still have squiggles.
Type number is not assignable to type string.
Right.
Okay. If you see, I have this like colon. There's a couple ways. TypeScript's pretty flexible on how you define things. So I don't actually have to. It can do type inference. So like if we look at quote, it knows it's a string, right?
So very similar to what the var keyword was doing in C#. It was inferring based on what's on the right side, and I have to give it the type if the compiler can't infer it. In this case, I would imagine if TypeScript couldn't infer it, which I don't know why it wouldn't, you would have to do the type, right?
Look at this. This basically is how you this is how you break TypeScript.
Is this how you just bypass TypeScript completely and go back to raw JavaScript?
Absolutely.
Okay.
So you can assign the any keyword as a type to anything in TypeScript, and that just basically turns off TypeScript. So if you want to do some dirty things in JavaScript.
Did you notice I just involuntarily
I
shivered there?
Right? I wanted to also show that you can set using the as keyword. Wait, sorry, that's going to be, well, it won't make a lot of sense. You have to have it declared out. It won't make a lot of sense because this is just a string and you can infer from that being a string. But when you're doing something like having an object and you've got like a custom type, I don't know, Steve's type,
right?
Where Steve type has a property of anopoly. I don't know how to spell that. And so I'm going to declare out that anopoly is a string. So if I wanted to do this, I would now change this to Steve type. And it's actually, oh, sorry, got to do an equal sign there. There we go. It should tell me if I actually get IntelliSense here too.
Oh,
so,
yeah.
And if I try and set this property to a number, it's not going to let me.
Right.
Conversion can't happen. So,
can I ask a question about
Yeah.
casting? I don't want to derail you anymore because I know you've got a significant chunk of project corner to get through. But
I do.
Could I put like a cast of string in front of that 1, 2, 3? Would that work? Like I can in C# or in some, not for string to int, but I can cast one object type to another, assuming the conversion is possible.
Yes, you can.
Okay.
I think. There's a number type. Yeah. Number dot.
Oh, you'd have to do like.
Yeah, there's like a
Okay.
String.
Interesting.
Like that, something like that. I don't remember the exact syntax. Right. Anyway, so you get the idea. Yeah. So I will show real quick too. Like I said, you can't just run TypeScript. It's not going to work, right? I want to show that out too. Hello, chat. Michael's also telling me to do lowercase s. You can do lowercase s. You can do uppercase s. Either or.
Doesn't matter.
With the types. So if I try and run with Node, right? This is how you usually run a JavaScript file.
Right.
Whoa.
Steve
type. No such thing as Steve type. That's like not. Now, if I take away that, it might run, actually. I don't know. I don't remember if this will work or not. I might not like the file extension. No, it still runs. Because remember, JavaScript is valid TypeScript. Right. So just because it's got the TS file, it can still work. Now, let's say I want to have that back in and we're actually using it, whatever. So there is a tool when you're working with JavaScript called npm. It's your package manager, basically.
Right.
Like you told us about.
Like we saw NuGet with Sharp, yeah.
So npm is how you pull in projects to work with both as libraries in the code that you're writing and also like command line tooling stuff. So like when you're actually, I will do, this will, npm init makes this thing called package.json. And this is where it tracks a lot of stuff. We don't have any dependencies yet, but I want to save npm install -- save dev. And this means I only need this dependency when I'm developing, right? Not when I'm running this code, like in production, for example.
Okay.
I'll install TypeScript, right? And then I can start executing things with TypeScript. As you can see, it added the package here.
Okay. Yeah.
So I can do things like convert this TS file into a JavaScript file, right? Or transpile it, I should say.
It gives me an actual JavaScript file.
Correct. So you can do it that route. You can install it, add it to your project, which is, I would say, like 100% of the time what you should do. The other thing you can do is there is a package called TS Node. And if you notice, I've got npx now instead of m.
I was about to ask you about that.
Yeah. npx lets me use the library from npm without explicitly installing it into my project or anything like that. So it's just like, I want to use this command line tool for, singular use or just whatever, right? This ts-node will actually execute hello.ts file. So it will in a temporary folder somewhere on your computer.
Right.
It'll do the compilation, and then it will, or the transpilation. Sorry, I'm going to keep doing that. It'll do that for you in a temporary folder somewhere, and then it will run that .js file. But you won't see it in our directory.
It won't update package.json.
Correct.
Okay.
So I can actually run that. There we go. Hello, chat. As we saw, when I try and run this without transpiling, it doesn't like that Steve type. Doesn't like that Steve type, which I understand.
Totally understandable.
I get that, right? No, I'm just kidding. I love the Steve type. Come on. All right. So one other thing too is let's see if I have the TSC. So this is like the TypeScript compiler. And actually, like they refer to it as compiler.
They do. I find that a bit strange, right?
It's kind of like one of these pedantic things, right?
Yeah,
like people say transpile, compile. Yeah, right. You're not really compiling. You're just like putting into a different language. Like compiling generally means that you're doing it for like a chipset, like a certain CPU chipset, and it's going down into maybe a single binary or like a DLL, like in C# that can run on the CLR or, whatever, right? I get where people are coming from. But what I wanted to show is like when you do compilate or transpilation, you could just use this TSC and then it will generate. We got hello.js here, right? And so look, that Steve type is not there at all. Isn't that interesting?
Yep.
Like I said, TypeScript kind of isn't real. Like,
But I'm guessing that's
not real.
Maybe more of the case of because we didn't use the Steve type.
No.
I mean, obviously there wouldn't be a Steve type in the JavaScript file, but would there be an object with properties?
Maybe. Let's see. Oh, see, and look, it complains.
Oh, look, it's forcing you to initialize it.
Yeah.
Right.
I could actually turn that off. So the question mark means optional.
Yeah. Well, we call that nullable in C#. Yeah.
Yes. So let's see. Oh, see, there's no type, nothing.
Wait, go back to the JavaScript file again.
Yeah.
But there is a Steve object.
There is a Steve object, but it doesn't tell us what type the Steve object is.
Right.
That doesn't exist. That's not real. That's just only when you're working in TypeScript.
Okay.
Kind of interesting, right?
Yeah.
Now, if I make that, required, and I do an opoly again, I don't know why this is complaining. I'm not redeclaring.
Not redeclare?
Steve, am I?
Steve. Yeah. There's only one Steve.
There
which
is.
Some would say is a good thing. Marie has a question for you, by the way.
Yes.
Says, can you import a JS library using TypeScript?
Yeah. Import, export. Those are some complicated things to get into. We probably don't have time to get into it deeply, but yes. So the other thing that TypeScript does is if you tell it to, right? This is a feature in that TSC compiler that you can turn on. It will generate what are called type files. So for example, if I want to work in vanilla JavaScript, this is oftentimes how people refer to the various types of JavaScript. This also is like a browser convention. I just said the word vanilla JavaScript. It means like pure, unadulterated JavaScript, right? Nothing added in. Oftentimes people will talk about React or Angular, and then they'll say, well, I built my browser app in pure JavaScript. That means I didn't use a framework like one of these browser-based frameworks. Also means they didn't use TypeScript, et cetera, et cetera. Anyway, using those type files that get generated, you can actually, at development time, use npm to download those type files that get generated and then still get IntelliSense in plain vanilla JavaScript.
That's useful, right?
Yeah, but those don't get included typically in like the thing that you ship out to the browser or to your server.
The dev time experience. Right.
That's right. That's right.
Okay. I'm just looking at the clock.
I know. I know. It's
I
crazy.
really have taken up all your time today, haven't I? I'm sorry.
You sure did. You sure did. That's
and you were
fine.
so excited about your project.
We're gonna get as far as we can. Let's see. Okay, so I'm going to make my project today, Steve.
Right.
From our last episode. Yes, you can pull via npm read. Yeah. Oh, and so hold on. That's point of clarification. You can pull from npm if it exists. So if the library developer bothered to make a types file for their library and it exists, then you could pull it from npm. They may not. They may not have. When you're working with things like Node.js, which is like the standard library, features of Node.js, there is a types/node library, and we'll see that later on when we.
Oh, so what you're saying is that the type information is a separate package in npm.
Yes,
it's not built into. Okay. Right.
Yeah.
Okay.
It's actually, like I said, on the compiler, an option that you say, I want you to generate a types file. I forget the actual name of the option, but anyway, that's what you do.
Okay.
Okay, so Steve, inspired by our last episode where we talked about cards.
Yes.
Remember, we talked about playing cards.
Yeah.
We talked about my favorite tarot cards. We talked about Magic the Gathering cards. Yeah, I grew up in the 90s, Steve. I was, I won't tell you how old I was in the 90s, but I had part of my childhood in the 90s at least. So you can figure out maybe roughly how old I am.
Okay. I'm doing the math in my head on mine.
Don't you dare. Don't you dare. Anyway, so a big thing in the 90s was collectible cards.
Yeah.
Well, I mean, collectible cards. Baseball cards, for example, have been a staple for a long time, but it really exploded in the 90s where like Marvel, like the superheroes, they had like collectible cards that you could buy. And then there were like Pokemon cards. That was beyond my time. I was too old for Pokemon cards personally. Right. Magic the Gathering, like I already mentioned. So I thought, how cool would it be to be able to create your own collectible card set, right?
Okay.
And so I want to create like the platform, right? All the features and functionality that you would need to create your own collectible card set. Then I want to make cards for all of the AWS on-air hosts.
Okay.
What do you think about that?
Yeah, I think that's cool.
You into it?
Yeah.
So we're going to use generative AI to do that. So I have no visual artistic bone in my body. I could barely write with a pen, like let alone draw any. I like, you can ask my handwriting. It's atrocious. So I can't create the images, but guess what can, Steve? Computers. Right. So we're going to use generative AI to do things like generate a text block for me about, the card that I'm designing.
Okay. So it's got like some kind of description about the card, like who's on the card.
Yeah, because like especially the Marvel cards, for example, they would always have like the biography of the character, right? And so instead of having to write all that, of course, Steve,
which is a creative endeavor, right? Which is probably beyond you.
Wow. I have an English degree, Steve. I do know how to write, but I'm lazy. That's the point.
Right. That's more where I was going. Yes.
I'm lazy. It's not beyond my capabilities. I choose not to engage my capabilities.
Okay. All right.
Big difference. But what is beyond my capabilities is making the artwork for the card. I definitely can't do that. My sister can. I could ask her to do it. But instead, I'm just going to ask the computer to do it. And we're going to use generative AI to do that.
Okay.
You may have heard generative AI being tossed around lately. It's things like stable diffusion. Don't you love that word? Stable diffusion. You know what that means, Steve?
I probably have to go and look it up.
It just basically means taking a text block and turning it into an image. Like it's like machine learning. Machine learning talk.
So you ask for something and you get an image back.
That's right.
All right. I'm all ears. Let's see it.
And then, of course, there's Chat GPT, right? That's taking the world by storm.
I've heard of, yes.
Yeah, so you can ask it to write descriptions for you, to finish your sentence, basically. I should have paused there. I should have said finished your and seen how you.
Paused. Yeah.
So yeah, I mentioned the Ouija board earlier, Steve. That's like the world's first generative AI, in my opinion. So, like, think about that, right? Ponder that.
I'll think about that while you're working. Yes.
Okay. So, what should we do first, Steve? We're gonna either we got two paths to go down. So we're going to build a REST API for me to consume these generative AI models, or we're going to build the generative AI models. We got two things that we could do. I'll ask chat. I'll ask Steve.
Yeah.
What's more interesting?
Give me the options. Give me the options again.
One path, we can start building our REST API,
right?
Learn about how to containerize it, and push it out to our container platform on Amazon or on AWS called ECS.
Yes.
Or we can go look at SageMaker and see how to get a generative AI endpoint in probably the fastest way possible.
Which one's going to get us to seeing a card first?
Probably the SageMaker path.
Let's do that then.
Okay.
Let's do that, and then we'll do the other one in the next episode.
Okay.
How about that?
Well, we'll see.
Since I've taken up all of your time today.
We'll see how much we get through.
All right.
So I'm in my AWS account. I've got SageMaker here.
Mm-hmm.
I
did.
did. I sure didn't I? Let's see. Okay, yeah, that's still working. Let's see what happens. Server not found. Okay, cool. Uh-oh, look, it's Aaron. Hey, Aaron.
Hello, Aaron.
Let's see. Huh. Very odd. Let me try a different browser.
Maybe we'll be taking the other route instead then.
I don't know, man. I don't know. Let's see. I've got to actually pull up my oh no, that's not working for me either. I think it's my internet actually. I don't think it's
so, yes.
Let's see. Yeah, we might be
doing it the other way around.
Let's find out. Let me move regions too. Maybe that'll help. I don't know. I had everything in US East or West 2.
It's local to you because I can get into SageMaker.
Can you get into US West 2?
Yep.
Okay. Yeah, it's something on my end. I don't know what's going on. All right. Best laid plans of mice and men. Okay. Let's see if do I have a domain here? We might just have to go through the entire setup. Oh yeah, no, let's see if this will open. So if you're setting up SageMaker for the first time, you'll have to create a domain in SageMaker. It's a lot of sitting around and waiting, so I don't want to show it. It's not difficult to do. It's just takes maybe about 5 to 10 minutes. And we're actually really short on time, thanks to Steve.
Sorry.
You're not sorry. You're not sorry.
But hey, you've got material for the next show now.
Right. Let's see. I did not confirm that this is an actual working domain yet. So anyway, we might pivot. Steve. Hey, look at this. Now it's working. Okay. Open Studio.
We're in.
This should work.
Famous last words.
I know.
Along with what could possibly go wrong.
Right? Murray's got a funny joke in chat over there. Okay, here we go. Jupyter Lab. So this is pulling up SageMaker Studio, which SageMaker Studio, from what I'm told by my friends who do know about machine learning, unlike you and me, Steve, is extremely useful and very easy for working with machine learning.
You're gonna have to zoom in, I think.
Absolutely. Don't worry about it. I'm actually just closing all this stuff. So, all right. So what you get when you get into SageMaker Studio, from my understanding, is like a big organizational piece around how you develop ML models, right? So it's got something for all life cycle, data cleansing, experimentation with a model, training a model, all that type of stuff. Way beyond our capabilities. Well, I'll say my capabilities. I don't know what your capabilities are. But it's got all kinds of stuff in here, and it's very easy to launch stuff like Jupyter Notebooks, which even a sub-novice like me understands what those are. Jupyter Notebook is like an environment for executing Python in like a visual way. We're going to see one. My thing that I am going to be using today is called Jumpstart. Remember we talked about Jumpstart at...
We did it one of the shows, right?
We did.
Was it reInvent? I can't remember.
It sure was. And I got lost a little bit, actually. I don't know where Jumpstart is. Oh, here it is.
On the left.
It's the big giant. Yeah. Duh. So let's go look at what Jumpstart is. This is, when I discovered this, I was like, this is awesome, because I don't have to know any of this stuff and I can just use it. So there are a lot of models in here, Steve, that are already trained.
I see stable diffusion now.
There's stable diffusion. I told you that word earlier.
Yeah.
All these icons you see with the emoji looking thing, this is a company called Hugging Face, and they do a lot with ML. I don't know enough about them to speak intelligently about them, but a lot of their models are available right here in Jumpstart as well, and they're awesome. I've actually been working with Hugging Face models when I've been kind of prototyping this out. So let's take a look at this stable diffusion one. And we can see they even I love this, Steve. Like they give you a description of the model and then they give you an example. So like this is the input text: a magical dragon flying in front of the Himalaya in manga style. And then they give you the pic. That looks great, right? So guess what? All you do is click deploy.
So, yeah, I was going to say, how do we use it?
That's it. I just clicked deploy.
Just click deploy. That's it.
That's it.
Okay.
That's it. Like when I saw this, I couldn't believe it, to be honest with you. I was like, this got to be more complicated than this. And no, it's not. It gets a little bit more complicated to actually use the endpoint.
When you say endpoint, what do you mean by endpoint?
So what's happening right now is it's deploying out this pre-trained model, right, to some infrastructure behind the scenes. And then it's going to surface that model out to you, the user of that model, as an endpoint. It's called a SageMaker endpoint. And so it's just it's an HTTP.
It's just a URL
that you can send, whatever JSON data or other types of data that your model is expecting.
Right.
You just send it over that endpoint.
Okay. So like in the previous episode when we were doing the text to backmask, we deployed was it a Lambda function behind an API, and we had an API endpoint URL.
Right.
That we just submitted a post request to, right? This is the same thing. It's just SageMaker on the back end. That's
right.
Okay.
Marie's asking if there's anything like Chat GPT, and yes, there is. If you go back, if I go back to the Jumpstart here, so there's a lot of these models in here, like over 200, I think, 200 plus for sure. I don't know even in the vision models, there's like 293 here, if you can read that.
Okay.
But they have categories in here as well. And when you go in and search, so what Marie's asking about is under the text models, right? So some of these texts are text to image, as we see in this tag. This is text to text generation, which is what like Chat GPT does. There is a version of GPT. This is GPT-2, which Chat GPT is not GPT-2. I think it's GPT-3. And also it's trained with a bunch of other stuff. ChatGPT is from a company called OpenAI. It's really cool and incredibly powerful and very impressive. GPT-2 is not, I'd say, we're actually going to use GPT-2 to do the card descriptions. It's not as trained as ChatGPT is. So all
right.
I was comparing the two. Anyway, so let's see how our deployment's going, shall we? Still preparing. That's okay. I think I actually have something. I have some.
Well, while that deploys, is it now out? Is it done?
I already had some.
Oh, you already had one. Okay.
I believe. Let's see. Open notebook. That's what I want to do. So it also comes with, this is part of like I believe Hugging Face has the included this because I think we're using Hugging Face. This is a notebook that Hugging Face like shipped with this model too. So it's like all the setup you need. It does everything for you. In a Jupyter notebook, you can click into these boxes here and just like hit Shift Enter and it runs.
Oh, just like a REPL.
Yeah, exactly.
Right.
Except this is stuff that like somebody's already, written.
They've already written, right?
Yeah.
Okay, and hopefully tested.
Oh well, yeah. Did I miss something? Maybe. I don't know. We'll just keep going. When in doubt, just keep going. So let's see. Yeah, sure. Yeah, that's the one that we want.
So we're literally just following the instructions, running the code where it tells us.
Yeah.
All right.
So here's where we can look into the code. This might be where we're getting some inference, maybe. This is actually deploying it out. I don't need to do that. I already did that.
And this is Python code, right?
This is Python, yes. Let's see. Okay, here. This is asking, so let's see where are we passing let's see, query response, parse response, query response. So these are the methods. They're declaring out like some methods for handling how we're going to send the query to the endpoint, right? So the SageMaker endpoint, remember?
Okay.
Right. So we're sending in JSON.
Yeah.
It's going to take this query response and it's going to return the generated image here, right? And then it's going to use this library called matplotlib, which is a very popular Python library for doing scientific plotting and statistical analysis, stuff like that. And it's going to actually show the image. So we're just going to execute this.
Okay.
And then now, look, now we got the text. We're going to use that query
impressionist style
function up here, right? We'll just run the first one that they gave us. Oh, nothing. Hold on.
Did you miss a step?
Yeah, I think I need to create this model. I sure did. Okay, let's see. This might go out and deploy another one, which I don't care. But look, this is, me just clicking around and stuff. But this is how easy it is, right? Like, it's not that complicated.
I could do this.
It's extremely complicated,
but I could do it.
Very complicated to like actually make these models.
Yeah.
Things like that. But let's see if this worked. I just missed a step. Maybe. It hasn't errored yet. It's probably sending out the query, and it takes a minute to get something.
So we should probably explain, I guess, at this point, the relationship between why we moved to TypeScript and this, right? Because we're not implementing this in TypeScript.
No.
What you're going to do at some project corner, we probably won't have time today now, is you're going to wrap an API around this.
I don't have to.
It
gives me an API.
Okay.
But I'm going to then, make my own so that people outside of my AWS account can consume
this. Right.
Yes.
Right.
So there will be an API layer.
You're basically proxying this.
That's right.
Outside of your account. Okay.
Yes. Let's see.
That's helpful of you and friendly.
Did we get something? I know. I don't know that we got anything. I don't understand what's going on.
Can we get a picture?
I don't know. Let's see. I'm just going to re-execute everything.
Ooh, Marie asks, is SageMaker part of the AWS free tier? I don't know immediately, but I'm going to go and look for you, Marie. 1 second. I believe it may have some free tier.
Yeah, as I'm trying to fix this one, you look.
How do you fix that?
Okay, that's good. Come on. I don't run that one.
Yes, Marie is the answer to that. So SageMaker has a free tier offering. It says 2 months free trial. Let me drop this into. This is a really long URL. AM.
Is it?
I'm going to drop it to you. You might want to. Well, let me see. Actually, if you go to aws.amazon.com/free. So let me drop this into the chat. What I would do if it would let me drop anything into chat. You have this studio so locked down, AM.
I know.
Okay, so I've just put it into the studio chat. So if you go to aws.amazon.com/free, there's a category on the right-hand side that says machine learning. And if you click that, it'll take you, and the very first thing that's mentioned on there is Amazon SageMaker. So I hope that helps.
Very nice. I think I got it now. Let's see if this worked.
I'm anticipating my cottage.
I know. I know. No, I want to execute that. Am I not? Oh, there you go.
Ah, we have a cottage.
There you go. Okay,
right.
What do you want to change this to?
Let's go for the hamster in a British flat cap.
Okay.
Let's see if you can even understand what I'm talking about to start with.
All right. So it takes a minute, obviously, as we saw.
So just to go while it does that. So just back to the previous. Oh, there it is. Hamster in. Well, it's
not in.
Almost.
What if we changed it to like
wearing a British flat cap?
Maybe wearing. You can see how this is going to be great for generating card pictures, right?
I can. So I wanted to bring that back into the discussion here. So what you're basically the reason.
Oh, wow.
Look at that. That's awesome.
Wow. That's you, buddy.
I need to screen capture that. So
how about I want to do snail on a skateboard.
Okay. So the TypeScript discussion that we started today, and obviously we haven't finished, is going to be building that API and deploying it using TypeScript. Is that right?
Yeah. So, let's see. Oh, look at that snail.
That's
one radical snail, man.
It is very radical.
All right. So yes, we get, like I said, we get one of these endpoints, right?
Yeah.
And so in order to utilize one of these endpoints, you have to have an IAM.
Identity Access Management.
IAM role that allows you to invoke SageMaker endpoints. And you can limit it to a certain endpoint. But basically, we have, as part of, I believe the package is called SageMaker Runtime, maybe. We'll see it when I actually start building it, which is probably next time because we have 2 minutes.
Yeah.
We actually will use an AWS SDK. It will be the JavaScript v3 SDK to call this endpoint with the same information that we were just using in the...
Instead of being in the console,
right?
We're just going to write an app that uses an SDK to call the endpoint with the payload.
Right. I'll give you a preview because
I
don't come unprepared totally. Usually, I was going to write all of this as we and use like my existing code as a cheat sheet, but so I'm going to use, again, this is all TypeScript code. I'm going to use a library called Koa, which is one of the more popular server implementations for doing REST APIs in JavaScript. Express is probably the other big one. We could talk on next episode why I chose Koa, that type of thing. But basically what I'm going to end up doing is writing an endpoint. So right now I just have an endpoint called root that just sends back hello world. Yeah. I'm going to containerize it, right? Like build a container, deploy that container out to ECS. And then once we actually get that running, I'm going to start making changes to the endpoints, and I'm going to build a card description one. We're going to pull in the
you're building a model.
That's right.
Not a machine learning model. You're building a type model.
That's right.
It's like we were using in Monopoly.
And so we're going to get like card description endpoint from the environment variable. And then when my user calls my API and does a post, I'm going to pull off of the request body. Look, I defined out an interface up here. It should have a variable called, or a property called prompt.
Yeah.
And then I'm going to construct the invoke endpoint command. This is from the AWS SDK. And this is me actually sending out this data from my API to my deployed SageMaker model. I wonder if I have enough time to do this real quick, actually. Let me see. Because I actually have this deployed.
So while you mess with that, let me make some
go for it.
About what you just showed. So if you've not seen any of the AWS SDKs before, what I just showed you is how you typically call, typically call an AWS service API. So you might be sitting at home thinking, okay, I want to call this particular API on this particular service, right? So I have to form up a HTTP web request in whatever language I'm using, and I've got to fill out the query parameters, I've got to fill out some headers, I've got to fill out the body, and then send it over the wire, right? So what the SDKs do is they abstract that away. Remember, we were talking about abstraction very early on in the program, about abstraction levels of languages, right? The SDKs abstract away calling those AWS service APIs. So instead of using wire level grunge and then needing to worry about, do I need to pass JSON? Do I need to pass XML? What query parameters do I have to put in? What headers do I have to put in? You just literally fill out an object of a type related to that API, and the SDK takes care of sending it over the wire as XML or JSON as a HTTP request, getting the response back, and then translating it back into an object in the language that you're working in.
All right.
It becomes just like calling any other method on an object.
As a preview for next time, Steve.
Preview for next time, yeah.
I ran npm run build and npm run start, which basically started up on my local computer, right? My API written in Koa.
You're running this locally, yes.
Right. So this is in TypeScript, written using a framework called Koa to do the REST API stuff, which we'll get into way more in detail next time.
Yep.
This is running with AWS credentials in my local machine, so it will have access to go out and invoke that SageMaker endpoint. I have another SageMaker endpoint using the GPT-2 model. I deployed that GPT-2 model. So I can say, tell me about a snail that loves to ride skateboards, basically, right? So I'm going to send that prompt to my API, which is in turn going to call that SageMaker model, give me an inference, and then send back a result. Let's see. Let's see if I got it. As a preview. Oh, there you go. Yeah.
Oh, I know.
I think that alligators are a little bit creepy. Yeah. You never know what this thing's going to come back with.
And hopping. Wow.
It's weird. It's bizarre sometimes, right?
Yes. Okay.
So that's what you get out of it. Some of it's useful, some of it's not, maybe. And as I said, it's not as refined as something like ChatGPT, but this is, again, I didn't have to build this model. I didn't have to train it. I didn't have to do anything. I just deployed it.
Yeah, I mean, that's the bit I also found interesting was, as you mentioned, right, you and I covered Jumpstart as an AWS on Air thing from reInvent, I think, right?
Yeah.
So the fact that I can wrap that endpoint behind some code and then call it from something else. I didn't even know you could do that.
I know.
Right. I'm sitting in there thinking I should convert this to C#. So
and look, we're going to use the CDK. We're going to use the CDK to actually define out all of our infrastructure.
Okay.
Too. So we're going to build an ECS cluster. We're going to deploy that API into ECS.
All right.
We'll have an application load balancer that we can hit. As you can see, there's the environment variable, card description endpoint, remember? Yep. So we'll get into all of this next time.
Yes. Michael's just asked, would I share the C# code? Yes. So AM, do you want to flash the GitHub repo on screen?
Yeah,
so I probably won't get around to putting it in there today, but I will put it in there where it is right now. And then actually that'd be interesting because then the next time I rev on it, you'll be able to diff the two. So you'll be able to see where I've made design changes as I've considered all those considerations, right, that I had in that file, right? So that will be an interesting development. So yes, absolutely, I'll share it.
Great. I dropped the link in chat. You know what I just realized, Steve, too? We did not play the transition into Project Corner. We totally missed it. Next time. All right. So I actually don't know when the next time we'll be on air is. Do you, Steve, offhand? I'm not sure.
It's normally about every 4 weeks. I mean, this one has been a little bit closer because we're catching up after being a little off schedule.
Right. It should be in April, for sure. If you want to go and check, we have a calendar available on twitch.tv/AWS on air, which I believe we got a banner for that to follow.
Roughly 4 weeks from today.
Yeah.
So, and we'll ping on LinkedIn and Twitter ahead of time that the show's coming up. So
follow us on whatever social you would care to. LinkedIn, Twitter, we post on both. Go join that Git repo too, because all of the Git repo all of the code will eventually make its way onto that Git repo. We've already got the code from our first 2 episodes there. Shall we do a shout out to the other shows on the channel?
Yes. Yeah, we should do that. Shout out. Go for it.
Me? Okay.
Yeah, you go for it. Yeah, you. Yeah.
So first of all, if you were new to the AWS On Air channel, welcome. You are in the right spot. This is one of the best places to get the latest and greatest information about all things happening on AWS that you can find. Every Friday, there is a show for AWS On Air that announces, or that goes over the announcements of the week, right? So highlights some of the recent launches that we've seen from products and services at AWS. All right. That's number 1. Fridays at 1 p.m. Pacific. Is that right?
No, midday Pacific, isn't it?
Noon. Yes.
Yeah, noon Pacific. Yeah.
Noon Pacific. Thank you. Okay. So that's the first show you should definitely check out. Number 2, we've got Jillian Ford's Startup Show. I believe that runs on Tuesdays. I think at 10 a.m.
Actually, you know what? I summarized these in this week's.
You did. You should link the blog post.
Let me go check the blog post. Yeah.
Yeah.
All the shows are listed. There you go. Let me drop this link into the chat and you can throw it on screen.
If you want to learn all about the startup world, how to build your own startup, how to build your own startup on AWS, go watch Jillian because she is incredible. She's amazing, expert in that field. And she does a show, I believe, almost every week. Then we've got Lockdown with Kyle, which is our security-focused show.
I just dropped the link into the studio chat. And if you want to throw that up. So if you scroll to the bottom of that blog post, there is a list of all the shows and a brief description and when they're on. So you might find that useful.
Obviously, you have been. You should go check out Kyle's security show called Lockdown. Obviously, you've been watching Code Corner with me and Steve. If you are just joining us here at the end, we do everything from beginning all the way to more advanced projects to help you along in your coding journey, both with AWS and without AWS. So not everything is AWS centric here on Code Corner. So we also have a show that I run with co-host James Spencer called Step Up Your Game Day. We did talk about game day in today's episode. I almost always try to, but game day is a great hands-on environment to learn AWS. It is a series of challenges that you and a team have to come into a real AWS account with a real deployed architecture and solve through that architecture. You'll implement new features of the architecture. You'll fix broken parts of the architecture. We just played a game yesterday with Richard Boyd and Jim DeHart, which was awesome. You should go check it out if you missed it. It was Richard is very funny, very funny guy. You know Richard, don't you?
I do. Yeah.
He's a little bit of a wild man. But we actually finished the quest, so that was pretty cool. Watch Step Up Your Game Days on Wednesdays at 11 a.m. Pacific, usually about every 2 weeks or so. And then, of course, Steve, we've got Under the Hood, which is a newer show to the channel, all about, I believe, EC2. So
yes, cloud infrastructure and EC2. I think the last episode they were talking about EC2's Mac.
Oh, cool. The Mac,
I believe. Yeah.
Very nice. Oh, step up your game day. Yeah. So you should be able to go back on. Let me find the link real quick. Do you want to summarize the events, Steve, as we finally wrap up? So AWS On Air does events, right?
Oh yeah, you'll find us at events. Yes. So AWS summits that occur around the world. We don't do every one of them, but we're at quite a few in North America and the occasion and a couple in Europe. So the Paris summit, which is coming up on April 4th.
Yes.
Aim and I will both be hosting the show from there, bringing all the latest news from the summit, and we may even have some impromptu code corners. Although those will be limited to 20 minutes, but we may well have impromptu code corners. So there's the summits, there's the London summit, which is in June. We'll also have the show live streaming from there. AWS On Air, not Code Corner. You'll find us at reInvent, live streaming from there.
Reinforce.
Reinforce. Are we doing Remars this year? I don't know.
I don't know.
We did last year. I don't know if we do. It's on this year. Anyway, but yeah, look out for us at the shows. It'll be like a special show. We did a special show for Pi Day.
Yeah.
Tuesday, just gone, since it was March 14th, 3/14 if you're in the US. So Pi Day, which is, I think it was the 17th birthday of Amazon S3.
Yeah, 17 years.
Yeah, so I haven't watched that show yet, but that should have been fun.
Yes.
So yeah, there's a lot of AWS On Air.
There is a lot of content here on this channel, and a lot of it featuring Steve and me actually too. So you'll catch us across all these different avenues and shows and things. So thank you all for sticking around for such a long time. You know, I mean, Marie's been here since the start of the show. She's been with us almost 2 hours. For example, but thank you all. Michael was here for a long time too. I remember. I think Sylvia too. A bunch of people that stuck around for the entire show. This is why we do it. We love talking with you all. We love seeing all the stuff you got to say, all the questions you've got, all the opinions, and another great episode, Steve.
I enjoyed that. Yeah, that was fun. So next time round, we'll take another brief look at where Anopoly has gotten to.
Yes,
and then we will really dive into your TypeScript and finish up that project corner.
Yeah. Well, I know we had some requests too for some languages. This is another thing too that we always ask, and you can like send us a message on you know, one of the social handles, whatever.
Yeah.
If there's a language you'd like us to cover in Beginner's Corner, for example, happy to do it. So we've heard a lot of people ask for Rust. I think some people have talked about Go in the past. I'm a big Go fan, so I'd be happy to cover Go. But if there's a language that you'd like us to talk about and you know, cover in Beginner's Corner, we're more than happy to do it. So let us know. Let us know what content you'd like to see. We are way over now, Steve, 15 minutes or so, but I don't believe anybody's coming on after us. So, all right. We have to go, though.
We do.
Thank you all for watching. We'll see you next time. Come check out some more shows on AWS On Air and hope to see you around.
All right. See y'all.